अग्रीड हैं जी बिल्कुल.
चेक करना आपको हमने भेज दिया.
ओके.
सर भेज दिया सर.
हाँ जी. Are you there?
Yes sir.
My Zoom is lost. All right.
Stop.
Okay. Question number 1. Okay, we will do this so that we can revise the concepts also along way.
कौन सा सर ये पेपर का
No, no, physics.
क्वेश्चन नंबर 1 कौन सा सर?
Okay, so I'll just share the situation and we will solve it together. Let's see if you can recall something. Okay, so let's say you have two billiards ball. Okay, so you have a situation of two billiards ball and their masses are given to you. Okay, and both are of mass m. Say the mass is 100 grams. Okay, and they are moving in opposite direction. They now are moving with the same velocity but in opposite direction, and both are moving with, for example, 10 meter per second. Okay. Now when they collide, the collision lasts for a time period of 10 raised to power minus 4 seconds. This is the time for which the collision lasts. Okay, you have to find what is the impulse which is imparted to each of the ball. Okay, so the topic is impulse. Okay. So there are two billiards ball, mass is known, and they are in opposite direction, and they collide, which means they are in touch with each other for a very minuscule time period here.
पहली बॉल का मोमेंटम 1 kg मीटर पर सेकंड है.
Yeah, you have to do this now. No need of talking. Just start writing. You can analyze it. You can analyze it. You can think of the concept momentum, like you said. Think about it and then put it to paper. Let's see which direction you go to, and then we will discuss on your concept clarity. Where is that you faltered, if at all? Maybe you don't. other is they also, after the collision situation, is they rebound. This is after collision. So they rebound back with the same speed of 10 meter per second. This is at the time of collision, and then after the collision, sorry, the size should be identical because their masses are identical, right? So let's say the second ball and they rebound back with the same velocity. Let us see how you calculate the, okay, so that's your, okay, not bad.
सर ये तो कोलिजन वाला केस हो गया.
Correct. And they rebound back. So
Yes,
there
sir.
is, excellent.
मैंने impulse calculate करी generated by the first ball on the second ball.
On the second ball, okay.
It is 10 raised to power negative 4 seconds. है ना?
Okay. ठीक है, करते जाओ. So you have to calculate the of each of the ball.
Impulse and the same impulse.
So you're calculating for the first ball, which is the left ball. This
Yes,
one.
sir.
Okay. So if it is a left ball, it is moving towards right. So the momentum is positive. Why has this become negative? अच्छा, final.
Rebound, sir.
Finally,
Rebound.
final. ठीक है, rebound से. Perfect है. So what is the direction of the impulse? The
Yes,
impulse
sir.
is a
Like
vector.
negative है ना तो ये backward की तरफ.
ठीक है. total impulse. Okay, got it.
सर फोर्स निकालना है ना.
Okay, force निकालना है. So you have also calculated the second ball. Second ball का भी negative है. Okay,
हाँ जी.
interesting.
एक मिनट.
Very interesting.
I think मैं गलत कर रहा हूँ शायद.
Question was, what is the
इम्पल्स है एवरेज फोर्स में.
to each of the ball? Okay.
बट सर आपने डेल्टा टी दे रखा है तो
Right.
फोर्स नहीं निकालना है इसमें.
Okay. Second part, let's say the second part. What is the force on each of the ball?
So 2 kg meter per second impulse generated by the second ball.
2 kg. Correct.
But total impulse होगा.
Who's asked you to
The impulse,
calculate total
okay.
impulse?
Okay, impulse imparted to each ball.
There is no total impulse.
Sorry.
Is
Each ball.
what does it mean? The impulses which have come are equal and opposite.
हाँ जी.
What does it tell you?
Equal and opposite.
Yep. So
Curl
if I do J1 plus J2, it comes out to be
say
0. The law of conservation of momentum.
momentum.
Okay, ठीक है. Now you have to calculate the force on each of the ball during the collision.
डेल्टा टी आपने -10⁻⁻⁴ दिया है.
Yes, seconds. That is correct.
ठीक. डन सर.
2000. And second ball also the same, but with the negative sign.
20,000 sir. Okay.
This is for the second ball. This is so third part. The F1, the force on the first ball is minus 20,000 Newton, and force 2 has come out to be plus 20,000 Newton. Which law is being followed during this collision impulse scenario? Which Newton's law?
Third's law of motion.
Correct.
Every action has an equal and
But
opposite
they
reaction.
act on different bodies.
But yeah,
Is being enacted.
सर ये एक तरह से मिक्स क्वेश्चन था.
Third law. Okay. Second, question number 2. So there is a barrel, a gun barrel. Barrel.
बैरल क्या होता है?
Fire gun tank. Okay. Now
तो
it has a capacity to generate a force of 5 into 10 raised to power 5 newtons. Okay.
in how much seconds?
No, there is no seconds. So this force gets applied on this explosive material. Okay. Could be a bomb or something. A missile, maybe a missile, okay? Now another person comes and says, I am going to increase the length of this barrel. And the force will remain the same. My force of my, this gunship or whatever, my force will also remain 5 into 10 raised to power 5 newtons. There is going to be no difference between two of us except my length is twice of yours. So this is A and this is B. Question is, which missile, okay, this is your missile here and this is also a missile. Which missile will come out with more momentum?
I think shorter cannon वाली.
Explain.
सर क्योंकि जो है मोमेंटम कम लॉस्ट होएगा.
Loss of momentum, what does that mean?
Like
Oh, you can explain, no problem, but you have to tell me what do you mean by that. I'm good with your answer. Okay, fine. So you said it has something to do with loss.
कैसे करूँ मैं इसको?
देखो, see the way you think is, and this is more of a practical question because if you notice, see in these scenarios, the mass, okay, the mass which is this, and the force which is generated by the barrel or whatever it is, right, is generated for a time for which they're in contact with each other, and they're in contact with each other for this length throughout the length. So here the length is shorter, right? Shorter length, but here the length is higher. If the length is higher, then the force and mass will stay in contact for a longer time period. Right? So what happens because of that? The impulse which is imparted becomes, and the impulse that gets imparted here T1 is going to be shorter than T2 because in the longer scenario, where the length is long, the force and mass will remain in contact for a longer period of time. So T2 is greater than T1 and therefore J2 will be greater than J1. इसमें क्या चाहिए थी कि you should have it is difficult to imagine that the force and mass stay in contact throughout the barrel, which means throughout this machine, the force and the impression
पर
is
J1 में ज्यादा होगी या J2 में ज्यादा होगी?
जिसमें ज्यादा टाइम पीरियड के लिए आप कांटेक्ट में रहोगे फोर्स से.
ओके.
So it's more of a cannon, right? A cannon being thrown. All right, one more scenario. So you have a car which is coming. This is your car, okay? And what a car finds there is a hut here. There is a hut, okay? And this is made up of fiber. Fiber as in very soft material. You can say anything like fodder bhi ho sakta hai, what they have, right? And in the second case, the car is seeing a wall, a bricked wall. Okay, so this is your wall. Explain the difference when the car strikes this and when the car strikes this. What happens to the car? What goes on and why?
ब्रिक की वॉल से कोलाइड होगी तो कार क्रैश हो जाएगी.
Yeah, agreed. Reason.
रीजन ये कि कैन वी से कैन वी से कि लाइक वॉल का जो लाइक मास है वो कार से ज्यादा है.
Okay, so you're saying the mass of wall is greater than mass of car, okay? And here the mass of the fiber material, so I'm saying the mass of fiber material is equal to the mass of the wall. So we'll put this story to rest. Right, so I'm putting it to rest. Okay, it makes no difference.
Okay.
Only thing is obviously the properties of material are different. One is completely very solid.
मास भी इक्वल है दोनों मटेरियल्स का.
Yes.
ये नहीं समझ आ रहा क्यों एक्सप्लेन कैसे करेगी.
That was my question. Please explain.
लाइक
Question ही वही है ना. Explain.
वॉल के सब ब्रिक की वॉल के साथ टकराने से कार क्रैश हो जाएगी.
Right. You're right. You're right. You're right actually. That it will crash.
बट क्योंकि ये कम फाइबर साथ वो कोलाइड करेगी तो क्रैश नहीं होगी क्योंकि वो सॉफ्ट है.
Okay.
बट Why? Why?
Precisely. What happens
Why? Or
in
why it happens?
that is the only question I have. I don't have any.
Just thinking like क्यों होता है?
Gee,
Equal and opposite reaction. No. Um. Sir, I'm like
okay, see,
ये थोड़ा hint दे सकते हो कैसे like explain करूँ?
you have not uttered a word about explanation. तो hint तो क्या है मतलब? See, in this
मतलब
case, if you see, जब कार इसके through जाएगी, what will see? There are two things which are going to happen. One is this car has a momentum, right?
हाँ जी.
When it goes and collides with this, two things happen, right? F gets generated, and there is a contact time. So mv, which is a momentum, right, is with the car. It gets like a ball hitting the or two collision only, but one of them is stationary. That is the only difference, right? और तो कोई फर्क है नहीं. This is stationary. Two things at play. One is a force, which is the equal and opposite force that gets generated, and the other it's T. Tell me, in both the scenarios, where will be the contact time higher?
Contact time would be higher in the fiber material.
Right. So let's say the contact time is higher. So T fiber is
Fiber.
greater than T wall. Agreed?
हाँ जी.
What is the force generated in case of fiber and as a collision course versus that of a wall? Compare force of collision, which is the
Contact
equal and
time.
is known to you. But now question is the other thing, which is a equal and opposite force that gets applied on the car is higher in which case?
Sir, higher
Wall,
in wall, sir.
wall. So less, right? So point is, in the first case, this is what is happening.
Okay.
In the second case, this is what is happening.
ठीक है.
The time is very high, but the force is very low.
Okay.
But in the second case, where the car crashes, crash करने के लिए force has to be very high on the car. If the force is very high, T is very small because J has to remain same,
ठीक.
right? All right. Let's do one simple question. Okay. So you will draw free body diagram now. Okay. We will do an exercise for free body diagram. So this is your diagram. This is a block. The block is of mass 50 kgs, getting horizontally pulled by a force of 100 Newton. You have to label this diagram, show all the forces on this diagram.
सर मुझे बस एक चीज पूछनी थी. सर पुलिंग पुशिंग से इजी कैसे होती है?
Normal reaction. दिखा दूंगा अभी because kinetic friction की knowledge होनी चाहिए. Kinetic friction is mu n, right? So in one case, mu n plus n becomes higher, gets added. The pull, if you pull, the force looks like this. If you push, then you are, apart from weight, also pressing the body with this force.
ठीक.
So you get back a higher normal reaction. If your normal reaction is higher, your friction is higher. Draw a free body diagram. So
यहाँ से पुल हो रहा है, ठीक है.
हाँ जी, अभी we'll come to that. Free body diagram. Good question. ये मैंने आपको एक वीडियो भी भेजा था, but anyway.
कोई मैंने देखा नहीं.
हाँ, वो तो खैर expected है. Busy man. Okay, so this is your free body diagram. Question. Practice. Let's practice free body diagram.
क्या फ्रिक्शन भी दिखा दूं क्या मैं?
Frictionless है. Assume frictionless. Okay, so really don't need to worry.
ये मैंने बना दिया.
Let us check it. Normal reaction 50 kgs 100 Newton. ठीक है. Okay. Find acceleration. Find A. Very basic question, but फिर भी.
2 meter per second.
Square.
Meter per second square. Sorry.
Okay.
क्यों पूछा ये?
Okay. One more question. So this is a block. This is the second block. And this is your 10 kg. And this is 5 kg. On this diagram, draw the free body diagram. Frictionless again. Surface is frictionless.
External force applied हो रही है.
Yeah. Show all the normal reactions. Show all the normal reactions in your free body diagrams for this situation.
बना दिया.
Let's check. So you have shown. This is for which mass? 10 kg?
M1G is for 10 kg, M2G is for 5 kg.
M2G समझ नहीं आया. So you are saying this is 10 kg. 10 kg is being pulled. This is what?
Sir, N1 is the normal reaction of 10 kg block.
वो तो ग्राउंड से आएगा ना.
हाँ जी.
वो तो यहाँ लगेगा. ऊपर कैसे चला गया? How it climbed up? ग्राउंड को प्रेस कर रहे हो ना आप?
हाँ जी.
Okay. Second thing is whenever you draw a free body diagram, the two masses are shown independently as a separate entities. Why you have mixed them up? It's a free body का मतलब क्या? It's a free body, which means it has nothing on it as if. You have to show it independently, like a complete body. Make sense?
Yes, sir.
So just draw 10 kg or 5 kg separately. No mixing up. Five is not on the ground.
हाँ जी सर, पता है. सर ये बना दूँ.
Okay, let's check. Okay. Okay, so now, okay, let's discuss each one of them. So this is your block A, which is in touch with the ground, right? So this force is being acted on by which body? ये कौन experience कर रहा है? Who's experiencing mg? Earth, right?
हाँ जी.
तो अर्थ के ऊपर जो फोर्स लग रही है वो क्यों दिखा रहे हो? इवन इफ यू वांट टू शो, ओके, अच्छा, अब अर्थ के ऊपर आपने mg से प्रेस करा.
हाँ जी.
In return, Earth will give you a force, which is the normal reaction. Where is
ऊपर
that?
लिखा है. ऊपर लिखा है.
वो ऊपर है. Okay, got it. Alright. Earth का जहाँ contact हो रहा है, it's a contact force.
हाँ जी.
It should appear at the contact as a reaction. So please show it at the reaction. Which is here. ठीक है. Got it. And now this is also being compressed by a 5 kg force on the top, right? So
हाँ जी.
either they have a contact mutual force, action and reaction force. The 5 kg is compressing it, and it also compresses it back.
Yes, sir.
So, sorry, it is being compressed by 5 kgs,
हाँ जी.
which is equal to
5 M2G.
if this is m2. दोनों सरफेस यहाँ पे सरफेस टच में है ना एक दूसरे के.
हाँ जी सर.
Where is their mutual action and reaction force? You have to find the contacts. Where is the contact with the other surface? So it is also experiencing this force.
The 5 kg block.
10 kg block.
Oh,
The 5 kg block is putting a force of m2g also on it. उसका वेट भी तो लग रहा है इसके ऊपर,
हाँ जी।
वो भी मिस हो गया. This was a mutual force between them.
तो सर ऊपर की तरफ टोटल फोर्स लगेगी.
सिर्फ फ्री बॉडी डायग्राम बनाने को बोला गया.
नहीं सर, ऊपर की तरफ जो 5 kg ब्लॉक है
उसका कहाँ है डायग्राम?
सर नीचे बनाया है.
हाँ, उसको एक नॉर्मल रिएक्शन मिलेगा फ्रॉम द 10 kg ब्लॉक.
हाँ जी.
तो नॉर्मल रिएक्शन की वैल्यू क्या होगी अगर ये इक्विलिब्रियम में है तो? बट बोथ आर इन ऑपोजिट डायरेक्शन, माइंड यू. Magnitude wise they're equal, but this is upward, this is for equilibrium.
N is positive
N is positive, yes.
and M2G is
So
negative.
name it differently. This is normal reaction on the block A due to ground.
सर ये N भी है ड्यू टू ब्लॉक ऑफ 10
This
kg.
this is on the B due to A. ये B block है,
Yes sir.
ठीक है.
Yes, ठीक.
Okay, third situation. This is 20 kg. This is 10 kg. And this is 50 Newton. Please show all the normal reactions. Frictionless. This is A, this is B. First, find the normal reaction on A and normal reaction on B. Second, जो भी जहां जहां पे, find the acceleration of A and acceleration of B. And of course, you have to do this clearly with the help of free body diagram. First part is make the free body diagram. That's the first part. Normal reaction तो है ही है. Okay. Coming from Earth. Okay. Coming from Earth on 10 kg. Perfect.
The real take is 20 kg पे कौन सी फोर्सेस लग रही है?
Right.
तो 50 न्यूटन में डिस्ट्रीब्यूट हो जाएगा.
Right. वैसे तो हम पढ़ चुके हैं सब, लेकिन हाँ, डिपेंड, सबको याद है कि नहीं है. कॉन्टैक्ट फोर्स समझाया था मैंने. और तो लगाएगी ना।
नहीं सर, वो तो मैं बना रहा हूँ, रुक जाओ। तो जो इस पे जो फोर्स लग रही है, इसको सर मैं एफ मान लूँ, स्मॉल एफ।
हम्म, उसमें तो कोई साइंस का क्वेश्चन नहीं है ये।
बट सर जो एक्चुअल जो कनेक्टेड जो फोर्स होगी वो होगी M2F
अभी फोर्स नहीं, अभी
अपॉन।
फ्री बॉडी डायग्राम बनाओ पहले। आई थिंक यू जंपिंग।
सर मैंने बना दी।
ओके, ठीक है। तो क्योंकि दोनों बॉडीज टच कर रही थी एक इस जगह पे, तो इसको एक वापस भी रिएक्शन मिलेगा सेम अमाउंट का एफ का। इफ यू शो एफ ऑन 20 kg, दोनों के बीच में जो कांटेक्ट है यहाँ पे जहाँ ये मिलते हैं इस जगह पे भी, तो दोनों म्यूचुअल फोर्स ही हो गई ना फिर।
यस।
ये वापस इसको देगा। ठीक है, नाउ राइट द न्यूटन सेकंड लॉ।
न्यूटन सेकंड लॉ।
हाउ विल यू फाइंड
न्यूटन।
अदरवाइज नेट एक्सेलरेशन?
फाइव अपॉन 3 मीटर पर सेकंड स्क्वायर। नेट एक्सेलरेशन इज 5 अपॉन 3 मीटर पर सेकंड स्क्वायर।
Okay, what is the value of F and F? The mutual
एफ
forces.
लॉ ऑफ मोशन 113 बाय 110 बाय 3 न्यूटन्स।
ठीक है, थोड़ी क्लैरिटी आई म्यूचुअल वाली।
हाँ जी सर, आगे समझ।
वेरी इंपॉर्टेंट। छोटे छोटे
यस।
क्वेश्चन है बट ओके।
फंडामेंटल्स।
फंडामेंटल, सीधा सीधा, नथिंग बिग, स्ट्रेट। Alright, let's take you to the next one. You have to again draw the free body diagram.
क्या फ्री बॉडी डायग्राम से बनवाओगे?
I think you need to know the basics, right? Without this, you can't apply Newton's law. क्योंकि लगना तो थर्ड लॉ और सेकंड लॉ है ज़्यादा। अगर फ्री बॉडी डायग्राम गलत हो गया तो वो बन नहीं पाएगा, क्वेश्चन कर नहीं पाओगे, मतलब बिना डायग्राम के। इक्वेशन तो ठीक है जो है, लेकिन if you have clarity on free body diagram, every question is same for you, because you know finally it will boil down to a third law or a second law, right?
ज्यादा बड़ा मत करो, ज्यादा बड़ा मत करो।
Okay, so this is a scenario. You have to draw the free body diagram. यार मैंने तो तुम्हें आंसर भी दे दिया।
हाँ हमने सही में आंसर भी दे दिया।
Why should I give you the answer यार? अपने आप बनाओ, लेबल करो, लेबल
तो
इट।
इतना समझिए, टेंशन वाला स्ट्रिंग से पुल हो रहा है
यस,
ऑन एन इंक्लाइंड प्लेन।
कह सकते हो। You just need to mark the forces. You don't have to worry about equation also. Free body diagram grip will mean that mechanics becomes very easy for you.
Dynamics is a subpart of mechanics.
यही है डायनेमिक्स. हाँ इट इज. स्टैटिक्स होता है. स्टैटिक मतलब रुका हुआ. मैकेनिक्स मतलब जैसे स्टैटिक.
काइनेमैटिक्स नहीं आता मैकेनिक्स के अंदर.
नहीं. वो लोग को डाल देते हैं मैकेनिक्स वन नाम रख देते हैं उसका. सम पीपल डू. There is a frictional force between A and B. You have to draw the free body diagram of both A and B.
It's frictionless.
Friction is there.
Friction is there.
Yes.
Okay. और सर हमें ये पता है कि पुल अप हो रहा है कि डाउन जा रहा है.
क्या पता है?
ये सर हमें ये पता है कि इट्स बीइंग पुल्ड अप और बीइंग. चलो ठीक है, क्या फर्क पड़ रहा है. सिर्फ हमें ए में बताना है.
दोनों पे. दोनों पे.
दोनों पे.
नहीं वो नहीं बताया कि व्हाट इज अ टेंडेंसी. यू हैव टू डिसाइड.
सर टेंशन को कैसे डिनोट करते हैं? टी से. सर ये मैंने बना दिया फॉर ए.
ज्यादा इंक्लाइन नहीं है.
इंक्लाइंड
A
बनाना.
पे tension is there is just one. So this is the place where tension is. Okay. Pulling होती है. Correct है. So that's your tension. That's your friction. Yes, because you're pulling it. Tension is pulling it. So automatically the friction is in the opposite direction.
मैं सोच रहा
And
हूँ
this
इंक्लाइंड नहीं
is
बनाया बस.
तो ग्राउंड पे बना दिए. Should have been drawn like this.
हाँ जी सर, सर मैंने इंक्लाइंड पे नहीं बनाया. मैं रीड्रॉ कर रहा हूँ उसको. Can we say it is inclined at angle theta?
Can.
मैं एक बार रेजोल्यूशन करके भी दिखा दूं क्या फोर्सेस की? बट जरूरत नहीं होगी. ये बन गया इंक्लाइंड प्लेन का ए।
mg mg is wrong. mg is vertically always. ये तो सिर्फ कोऑर्डिनेट एक्सिस चेंज हुआ है. mg is always down. In the new coordinate system, we split mg into two parts. mg sin theta, mg cos theta.
तो मैं तो थीटा भी नहीं मान रहा, एक्स मान रहा हूँ. mg cos x. Done, sir. Pre-body diagram of A is now B.
This is B or A?
This is A, sir.
But A is not on an inclined plane. A is on the other block. ये क्या बना दिया है?
नहीं नहीं, ये B है सर, B है.
ये B पे तो string है ही नहीं attached. Sorry. B only has one tendency, that B wants to go down because it has its own weight as a tendency. दूसरे एंड पे कोई वेट है नहीं.
जी बस.
अब फ्रिक्शन, if the weight is wanting it to go down, this is the only tendency, real tendency it has, then why is the friction in the same direction? If the only tendency it has to go down, then why is the friction acting also downward? No, the friction is here between the two surfaces. There is a friction between A and B. ठीक है, if the inclined plane also has a friction, you're good. But यहाँ पे भी तो होगा friction एक. ये friction is between which two surfaces?
Between A and B.
Correct. And since B wants to go down, the friction acts in an opposite direction.
दिखा दिया मैंने.
ठीक है. So you're also showing a friction between inclined plane and the block.
तो ये भी मेंशन है कि दो ब्लॉक्स के बीच में भी फ्रिक्शन है.
हाँ, ये नहीं मेंशन्ड है कि यहाँ पे फ्रिक्शन है. There is no friction here, say. But you've taken it is fine. So A is okay, complete. What is this?
This is a normal reaction.
This is a normal reaction from where to where? From who's giving it the normal reaction is my question.
Sir, the inclined plane.
The inclined plane is giving it a normal reaction, okay, in the new coordinate system. Agreed. But what about the weight of this particular A, which is also pressing it in the new world? ग्राउंड ने दिया, अग्रीड, ये वाला ना, यहाँ पे ये ए भी तो इसको प्रेस कर रहा है ऊपर से.
MAG plus MBG,
MBG,
mass of the block, mass of block B into G, and ये भी ऐड हो जाएगा, mass of A into G.
तो समझ में नहीं आ रहा क्या बोल रहे हो. The upper block is also pressing it. Where is that compression shown? Forget equation. Nobody's asking equations. I'm asking you the compression, which is this. So you're compressing it, right? You are also compressing it from the top. Call it NAB.
MAG कह दिया.
G कहाँ से आ गया? ग्राउंड होता है वो तो.
G
A on B. The normal reaction of A on B. या तो B A लिखो या A B लिखो. So that it shows an interaction between the two bodies. जो मर्जी नाम रखो, but define करो.
of A.
So This is normal reaction on B due to A.
हाँ जी
Now it is complete.
ठीक
ये तो यार स्ट्रेट इंक्लाइंड ही नहीं है, ये तो गलत है. दिस शुड हैव बीन इंक्लाइन. वैसे ही गलत है ये.
string is pulling it up, so friction will act in the opposite direction.
There is no string on B.
A sir,
A.
A है ये.
Yes. Agreed.
Done sir. Free body diagram on A.
Yeah, this should be perpendicular. It should be along N, this component. And this F should be along the incline,
वो थोड़ा सा
parallel to the
हाथ
incline.
आरा टेढ़ा हो गया,
हाँ.
but sir फिर भी
Redraw this. Doesn't look correct. Parallel means parallel, perpendicular means perpendicular. Never take x in this. It will create confusion. Always take theta.
अल्फा ले लेता हूँ.
चलेगा. इसको incline पे क्यों बना दिया? ये तो A है. A is not on the incline. It is on the other block.
मैं पहले भी A ही बना रहा था. नो आपने कहा था कि इंक्लाइन पे बनाओ.
मैंने ये नहीं बोला था.
तो मैं
मैंने
A
बोला था
ही बना रहा
inclined
था.
बनाओ. Inclined. टेढ़ा बनाना है. सीधा नहीं हो जाएगा या अपनी जगह नहीं बदल लेगा वो.
इसको फिर मैं हॉरिजॉन्टल प्लेन पे बनाऊं.
नहीं, उसी पे बनाओ टेढ़ा. सिर्फ नीचे B दिखा दो. एक लाइन दिखा दो कि B के ऊपर है.
ऐसे
और भाई ये you can always show it like this, that this is your situation. That's all.
ओके.
And now just work on this, and maybe you can, if you find it tough, ये वाला part हटा के just draw a small line here showing that this is on a block. उस पे फ्रिक्शन ऊपर था, इसमें ऑपोजिट हो गया. फ्रिक्शन इज ऑल्सो पेयर. ऊपर वाले पे फ्रिक्शन अपवर्ड था, इस पे डाउनवर्ड हो गया. No, I'm not happy with your NA. You have used NAB here to tell the world that this is the normal reaction on B due to A. So make it NBA.
लिख दिया NAB.
NAB तो नीचे यूज कर तो लिया. The normal reaction pressing B on A. Now you're pressing A.
MAG नीचे के forces.
Right.
Done.
Okay. Hopefully this has brought more clarity in your mind.
Yes, sir.
Okay. Okay. Let's use one more situation.
Helps.
Okay. So this is a situation of an incline again. Okay. So this is an incline. These are the two blocks. Okay. These are the two blocks. This is angle theta. You are pushing the two block system from here, F. Okay, and these are the two masses. This is an incline. You have to draw the
Free body diagram.
of each one of them.
Yes, sir. Got it.
No need of writing any equation.
Friction है inclined plane पे?
No, frictionless.
Frictionless, ठीक है.
It is given that both the bodies are moving upwards. So assume there is a friction. So if you're going up, the friction acts downward. Okay. What is this?
फिर उसे मैं MG बना दूँ.
MG बना दिया. Parallel. Make it along
Parallel
the
ही तो है
incline.
सर. Parallel ही तो है.
नहीं है, थोड़ा दूर जा रहा है. ये पैरेलल होता तो मैं ये बना लेता. Along the incline. Incline से एंगल बन गया, फिर भी पैरेलल है. Doesn't look parallel. Along the incline बनाना होता है, या ऊपर से बनाना होता है थोड़ा सा, so that it looks parallel. ये क्या कर दिया? Draw it along the incline and finish it off.
कैसे सर? Parallel कैसे दिखेगा वो MG? अच्छा मैं समझ गया कैसे दिखेगा.
ये बनाया तो था अभी. ये बस इसको यहाँ दिखा दे. ये just draw it here.
यार
ये मैं तो ऐसे दिखा देता हूँ पैरेलल बस. ये
अब सर आप बताओ ये पैरेलल है कि नहीं है?
ये ठीक है. This is good to go. थोड़ा ऊपर से बना दिया. Agreed.
MG sin alpha. This is alpha.
This doesn't look perpendicular. Yeah, sorry. Looks absurd.
Now it looks good.
Yes.
ये भी एक आर्ट है.
ठीक है. Cos theta, cos alpha. ठीक है.
And this is n of m1.
Coming from the inclined plane.
Yes.
ठीक है. Done.
This is for just मैंने सिर्फ अभी m1 का ही बनाया है.
बहुत अच्छी बात है. Just a correction. You forgot to do one thing. There was a contact here. So there was a normal reaction coming from this side also. At the point of contact, mutual action and reaction pair.
इसको मैं सर मैं
ये F इतने सारे F लिख दिए हैं. अब X लिख दिया इसको. Should not even use x, I think.
F of F
N
beta.
this is normal. Not a, I mean, it's a mutual force, but at least you can write something to do with
Fn लिख दो उसको
M2.
खाली Fn.
You can F, why don't you write it as F12?
F12.
So that you know it's a force experienced by 1 due to 2.
Okay.
So again a mistake. You forgot to add contact point. ये रह गया. Let me see your paper now. Okay.
कौन सा मैथ का?
Open with. Whatever. You continue to do. बनाओ.
और कुछ नहीं छोड़ूंगा मैं फ्री बॉडी डायग्राम में.
Okay. I'm sending you an assignment which you need to complete today night.
तो फ्री बॉडी डायग्राम से ही दे दो.
वही दे रहा हूँ बस. That's all.
काफी जरूरी होते हैं फ्री बॉडी डायग्राम्स मैकेनिक्स में.
इसके बिना you can't learn mechanics unless you have a very strong handle on this. So, अगला step equation है.
इक्वेशन तो अपने आप वो तो मैथ है.
Yes. That's the point.
ये फिजिक्स है फ्री बॉडी डायग्राम्स.
अच्छा इन्होंने ये दिया है ये show that
सरदार
ample questions करते हैं सरदाना.
जैसे मैं इतना नीट बनाऊंगा ना आप, it would be perfect. सर आपकी आवाज क्रैक हो रही बहुत.
हो जाएगा. Second with small marks. Something wrong with the speed. Clean करके गया दिखा के गया 200 Mbps, 120 Mbps. Let me do a speed test again.
मैं भी अपना कर लेता हूँ.
Continuously there is a problem.
मेरे साइड से भी हो सकता है.
God knows, man. Very difficult to. Let us see data fiber. Allow.
काफी खतरनाक स्पीड है. तब पिंग भी अच्छा है मेरा तो.
My speed is only 9 Mbps.
हाँ तभी से आपकी बहुत क्रैक हो रही है. तब मेरा पिंग भी 5 ms है.
ठीक है. Continue to do your question यार. That is your focus. Don't worry about speeds.
आपकी आवाज बीच में क्रैक हो रही है.
What is this force?
Friction.
इसमें क्या है फ्रिक्शन ऊपर? अच्छा ये था. ये वाली ना?
हाँ जी हाँ जी. Done sir. Free body diagram completed.
Let me see.
Of M2.
So नीचे से आ रहा है. You are compressing it. This is M2 you mean?
M2 yeah.
This is M2.
What
is this? Okay, this is
M2.
mass M2. This is frictional force. This is the normal reaction
परपेंडिकुलर है
फ्रॉम
mg
द,
cos अल्फा।
ठीक है, ये इसका अपना वेट है, ये एम जी कॉस थीटा, ये एम टू जी है, ये नॉर्मल रिएक्शन है, एफ एक्स है, ठीक है,
इट इज परफेक्ट।
गुड वन, ठीक है। नाउ आई एम सेंडिंग यू एन असाइनमेंट विच यू नीड टू कंप्लीट एंड टुमारो वी विल डिस्कस if you had any problems.
ओके।
Once you do this, then we will go to topic by topic. Small questions, very conceptual.
तो वैसे भी अगले वेडनेसडे को पेपर है।
वो तुम्हारा पेपर है, मेरी प्रॉब्लम ही नहीं है वो, दैट यू हैव टू मैनेज ऑन योर ओन। मैं
हैं?
कुछ और पढ़ा रहा हूँ तुम्हें, फेल हो जाओ उसमें अच्छी बात है, ठीक है जी, हो जाएगा कवर वो भी, उसमें कुछ नहीं है, ठीक है जी। सी यू टुमारो देन, आई एम सेंडिंग यू द असाइनमेंट, मेनी क्वेश्चंस विल बी देयर।
ओके,
ऑलराइट, सी यू देन, बाय।
बाय।